this is an example of a problem that's quite common in the exams that uses logarithms, but not in the same way as we've seen in the previous questions. For starters, I do not see any logarithms in this question. Okay, there's no logs visible at the moment. Now, the problem you have with a question like this, as opposed to the previous examples, is you cannot combine exponential terms. Not in the same way you can with logarithm terms, because we have the laws of logs. If you have log of something minus log of something else, you can combine them. We've got log laws that deal with that. However, 3 to the power of something plus 3 to the power of something else, you cannot combine in the same sort of way. So the question is, what do we do? So, first of all, there's quite a nifty trick that comes out here. What we'd like to do is connect these powers somehow. I want one to be some sort of multiple of the other. Now this plus 1, though, is going to ruin things for us somewhat, because 2x plus 1 is not an exact multiple of x. So the first thing we should do is split this up. So let's write this as 4 times 3 to the power of 2x multiplied by 3 to the power of 1. All I've done there is exploited the fact when you have two powers added together, that comes from the popular law of indices that state x to the power of a times x to the power of b equals x to the power of a plus b. I'm actually happy with this as it stands, so I'll leave that like this. And let's just tidy this up. I've got a 3 to the power of 1 at the end and a 4 at the beginning. They obviously combine to 12. So this tidies up to the following. Now, why is that a better presentation of the initial equation? Well, now we're in a better position. Why? Because this power here is exactly double that power. If you have a situation when one power is double the other power, it can turn into a quadratic in disguise. How so? Well, if I let u, and I'm just choosing an arbitrary letter, equals 3 to the power of x. Well, that's exactly the square of that, isn't it? Because that can be written as 12 3 to the power of x squared, because 3 to the x and then the 2 there, that becomes 3 to the 2x, which is the same thing there, plus 17 3 to the x minus 7 is 0. If you can negotiate an equation in such a way that you engineer it so that one term is the double of the other term, in other words, that one term, the power, is double the other power in the other exponential term, you can use some sort of substitution to make this work. Because once u becomes a 3 to the x, this just becomes a regular quadratic, 12u squared plus 17u minus 7, which solves to u is a third and u is minus 7 over 4. What you have to appreciate is I'm not trying to solve the equation for u. I'm trying to solve the equation for x. Now I made u is equal to 3 to the x. So now let's put that back in. So finally we get 3 to the power of x is 1/3. And 3 to the power of x is minus 7 over 4. I'd like you to stop at the video right there. Press pause. Look at those two equations. So we've got 3 to the x is 1/3. 3 to the x is minus 7 over 4. And tell me which one of those jumps out at you for a specific reason. I'm not going to say what. It should jump out at you and you should be saying, and I'm going to let you know what that is when you press play. So press pause and have a think about that. So, hopefully you had time to think about that. And what I was expecting you to think is that this one here is a problem. Why is this a problem? Because 3 to the power of x is equal to a negative number. That's impossible. That cannot happen. Any number, a positive base, cannot be raised to any power to possibly get a negative solution. That cannot happen. 3 to the power of x, 5 to the power of x, 8 to the power of x cannot equal a negative number. Now we know this because the graph of 3 to the x, for example, looks like this. The outputs are always positive. So you cannot have a negative number and you cannot have 0 for that matter. Now over here, 3 to the power of x is a third. You might be able to spot the solution there because I know 3 to the power of something equals a third. Well, 1 over means it must be negative, and the fact it's 3 on the bottom, you might be able to spot that x is minus 1. Because there's no solution there, therefore x is minus 1 is the only solution. Now, be advised that if this number was 2/9 or something where I wouldn't be able to spot the solution, you could use the definition of the log. Right? In case you didn't spot that, you could also say that's log base 3 of a third. If you type log base 3 of 1/3, the calculator will tell you it's minus 1 like we have. Okay, having seen that previous example, have a go at this one. A question like this would be about 6 marks, 5-6 marks. So let's see if you can solve this problem over here. Trying to be careful to get all the different parts of the solution that we discussed in there. So pause the video, have a go, and then wait for my solution and check that you've got all the different aspects of the working that I'm going to put, and of course arriving at the correct solution. Okay, so the first thing we need to do is to tackle this plus 3. We want to isolate the 10x power and the 5x power, because 10x is double the 5x, and we're going to therefore get a quadratic in disguise like before. So let's split this up. Remember, adding powers originate from 2 to the something multiplied by 2 to the something. So in this case, we've got 2 to the power of 10x multiplied by 2 to the power of 3. We will leave the next line as it stands to get this. 2 to the power of 3 is 8. There's nothing in the front to multiply, so I'm just going to stick that 8 as a coefficient. So I'm going to rewrite this as 8 multiplied by 2 to the power of 10x minus 8 2 to the power of 5x minus 1. And now we're ready to treat this as a quadratic. I notice this power is double that power, and therefore a substitution of the lower of the two powers, because that means that the u squared will be the one that's doubled, giving me a quadratic. So u is 2 to the 5x, and then this becomes 8u squared, like in the last example. Minus 8u minus 1 is equal to 0. Solving this quadratic gives you 2 plus root 6 over 4, or 2 minus root 6 over 4. And you would soon realise that if you look at that value there, 2 minus root 6 over 4, that's negative. It has to be, because root 6 is bigger than root 4, so the numerator is clearly negative, which means the whole thing is negative. Remember what we said in the previous example, that if you set 2 to the power of something equals to a negative result, that cannot happen. Right? There's no solution for x. So that actually won't give you any solution whatsoever. So I only need to solve this. Okay, so we have 2 to the power of 5x is equal to 2 plus root 6 over 4. To solve this final equation, which is effectively the solution to the equation, we need to use logarithms. 2 to the power of something is equal to a number. We use the definition of the logarithm. So that power, put a comma here, that power 5x must be log base 2 of this. That's just using the definition of the logarithm, which I discussed in a previous video. So log base 2 of this, just write that all in, 2 plus root 6 over 4. Be careful, log base 2 of 2 plus root 6 over 4, that's not the final answer. That's 5x. I'm looking for x. So then you have to divide that by 5 and leave the answer to a suitable level of accuracy. They would probably specify in the question. So, 0.
So let's make some ideas we've seen earlier in this chapter
with
with
this.
this.
We've got e to the x plus 4e to the minus x is 5. Why don't you think how you can have a go? It's slightly harder than the things we've seen before. You might have to play around with it a little bit. So why don't you pause the video, have a go, and see what you can do. It looks a bit like where we had the problem with 2 to the power of 2x and 2 to the power of x, where we try to force a quadratic. The problem is here, there are no other terms to split out, as it were, like we saw before. And also, x and minus x, they're not doubles of each other. So, let me give you a tip. When you have negative powers of e or any base, you want to try and turn them into positive powers. So the most negative power of e, you want to multiply by the positive version of that. So what I mean here, I've got e to the minus x. So if you times everything by the positive version, i.e. e to the plus x, then the negative powers will go. So let's say I had e to the minus x and e to the minus 3x. Identify the most negative power of e, and then times by the positive version. So in this case here, there's only one negative. The positive version is the same thing without the minus, e to the x. So times through by e to the x, and let's see what happens. So e to the x times e to the x. Let's see, e to the x times e to the x. Let's add the powers. So that's e to the 2x. E to the x times e to the minus x, well x minus x is 0, so e to the 0 is 1, so it's just 4 times 1, that's 4. And that's just 5e to the x. Then bring this across, and hopefully this is now familiar territory. This is your classic quadratic style question. That's double that, so you can use a substitution. U squared minus 5u plus 4. That actually factorizes quite nicely. U minus 4, u minus 1. So u is 4 from that bracket, u is 1. Remember, like we saw before, u is really e to the x, so let's bring e to the x into there and there. So we get e to the x is 4, e to the x is 1, and we've just learned that to get rid of that e, you introduce ln, which will give me x. So if you ln both sides, we get two solutions. Ln 4 from here, because ln of e to the x is x, and then ln of 4 is the right hand side, so x is ln 4. This is obvious. If e to the x is 1, well, what power of e gives me 1? It must be 0. So those are the two solutions. But also, if you ln both sides, ln of e cancel, so x is ln of 0, and ln of 0. Sorry, and then ln of 1 is